Design of light gauge steel frame for building structures with FrameCAD Structure. A tutorial series by engineer Siraj Biswas. Chartered Engineer, Institute of Engineers, India. Gold medalist in Engineering Stream, University of Mysore. M.Tech in Structural Engineering, IIT, Delhi. Sun Certified Java Programmer, Sun Microsystem, USA.
Friends, building structures with light gauge steel frame started around 2 decades ago. It was quite widespread during that time in US, Canada, New Zealand, Australia. Nowadays it has also become widespread in India. The most prominent software for design of LGFS structure is FrameCAD software, but there is very few tutorial available on that, and moreover the FrameCAD software has provisions of few codes which doesn't include the Indian code, and even those code it has taken some of its own coefficient on conservative side. So in this tutorial we'll try to design a LGFS structure in Indian context, whereas we shall match the wind load that has been generated by FrameCAD software with the wind load that should be as per Indian code, and the seismic base shear that has been generated by FrameCAD should match the seismic base shear as per the Indian code. So for that I have already prepared some Excel file that will be available in www.designsteel.in. First of all, we shall have a look at the drawings, which building we are going to model. We have taken a sample building in such a way that we could cover almost all the facets of FrameCAD software. This is the sample building we are going to model. There is a staircase. This is the ground floor plan. The typical external wall and internal wall details are also provided. You can find the PDF file and the AutoCAD file of these drawings in my website, as I've mentioned before. Let us go to the first floor plan now. This is our first floor plan. We'll see the section also. This section BB and section A also, in which the floor to floor height and other heights are given. Our next drawing is roof plan. This is the roof plan. This is the part we call it hip roof. This part we call saddle. This is a gable end. Again, this is a saddle. This is a saddle. This part is a hip roof, and this part is a hip roof. The roof has a position of around 600 mm from the wall. Now let us go to the section view. This is the sectional drawings. The roof has a 15-degree slope. The gable type of roof also has a 15-degree slope. There is a mild steel staircase. The design of mild steel has been already done. The sizes has been incorporated by the architect in the architectural drawing itself. Actually, this part has to be designed by the structural engineer himself. So, this part can be designed considering the load from the tributary. So this mild steel structural part should be designed considering the load from the tributary area. This should be actually designed by the structural engineer who is dealing with the light gauge frame design as well. This can be designed with STRUCTURE or ETAB or other commercial available software, but for small kind of things like this staircase or a portal, this can be designed manually as well. So I prefer to design it with STRUCTURE. That is the most widely structural software used for mild steel structural design in India. This is our section. So the section in this section, the MS column sizes, the MS beam sizes, everything is being given. So now next is a plan that has been prepared just to help in calculation of wind load magnitude and the seismic load magnitude. Individual floor plan, area, the corridor lobby area, the length of the wall, ground floor, the length of the wall in the first floor, all has been computed and table has been provided by the side. This has been done with the help of the Excel spreadsheet. This can be also downloaded from my website. So our next is seismic load calculation. Before that, we will go to gravity load and various live load. That shall be the part of seismic load calculation. This is our gravity load calculation, the dead load, the deck sheet, then the joist load has been also added to the total dead load, then the roof load, then the wall load. The external wall will have a different load and the internal wall will have a different load, but there is not much difference. So for all practical purpose, we can consider same load for same self weight for internal wall as well as external wall. It is we can treat is 0.6 or 0.61 kN per square meter. So this 3.1 shall be the floor load when we add to the 0.3 for the fall ceiling fixture. It's become 3.4, and for seismic load calculation also manually we will add the load of the joist. The joist is usually around 10 to 11 kg per square meter, so 0.11 kN per square meter has been taken in this spreadsheet. Now let us go to seismic load calculation, base shear calculation. Calculation of base shear has been provided here. The seismic weight has been calculated for ground story, then the first story, then the time period has been taken for 0.09 h by root hd, or just different. The building has different dimensions, x or y direction. So then flow distribution of the base shear has been calculated. So this is the seismic story shear. So seismic story shear. This spreadsheet is also available in my website. You can download it from there. We shall be designing our structure in FrameCAD with IBC 2012 LRFD, and we shall set the value in such a way that the seismic base shear occurred over the FrameCAD should be more than this. Next is our lateral loads. That is another lateral, that is wind load. So I provided a sketch in which where which all becomes A, which all become B, which all becomes C and B, D and C and D. As given, the wall area has been is also calculated. So the wind pressure has been also calculated. Yep. Then if you take the wind pressure of if you take the consideration of height of the building less than 10 meter as per clause 6.3 of 875 part 3, then we can reduce the wind pressure by 20%, so this factor becomes 0.8. So various coefficient has been also calculated. If you want to know in detail how this wind load is being calculated, you can visit my another series of tutorial design of structure with the STRUCTURE, in which I have discussed in detail how the wind load is computed. So these are the various wind pressure around 0 degree when there is a positive pressure, negative pressure. So ultimately our aim is to calculate what is the total lateral load. We have neglected here the component of lateral load in the roof, so that is very little for this building. So story-wise wind shear in x direction and story-wise wind shear in y direction has been calculated. So the lateral wind pressure generated by FrameCAD should be more than this. Then we can claim that we have satisfied our wind load criteria of Indian code as well. And then you have to see the uplift also. So FrameCAD takes a different type of coefficient for calculating uplift. So when we get the reactions from the FrameCAD, we must ensure this much of uplift, that is 1.661 kN per meter for the maximum span truss should be obtained. With that we can ensure that the uplift as per Indian code has been already ensured. Now let us open the AutoCAD file of our building that has to be modeled in FrameCAD. This is the AutoCAD file. The ground floor plan, then the first floor plan, the roof plan, and everything is there. They have been set in the layout. We'll copy this ground floor plan and take it to the FrameCAD software, and let us open the FrameCAD software. FrameCAD structure. You need to log in. If it is not logged in, this software has been already logged in. So if you are working in a farm or going to work, they will obviously provide you with a software. But for learning this tutorial, you can download it from FrameCAD website, and the software will run for 30 days trial period. So obviously you can have enough time to learn and practice FrameCAD software within that period. So this part is called status bar. You should always keep on looking this status bar while working on software. In this YouTube video, this whatever is written in the status bar might not be visible, but however I will be reading them as far as possible. But while you practice, you must keep on reading this status bar and act accordingly. The first command of FrameCAD software is bset, that is border setting. We have to create quite a number of borders to generate workspace in which you have to work. So let us type bset on the command bar. Bset border setting sheets setup dialog boxes appear. So here we can write the name of the company. Is sample. Let us be sample company. Retailer name. Obviously, it is not a FrameCAD software. Is not detail. It is actually structural design. So you can see SB delivery checked. Whatever is the date is date to today. You can provide some job number, say 1001, 1001, project name, sample building, project location, so Delhi NCR, project sample. Now we'll have 9 numbers of border for this project. So we'll set the 3 and 3, then sheet option. We'll change it to A3 sheet. Border scale is 1:100. Our building is, you see, our building is around 14 meter by 11.7 meter. Then there is a 3.5, so it is almost 15 meter by 15 meter. Let us go back to the FrameCAD file again. So for a 15 meter by 15 meter building, a 1:100 border scale is recommended. Units is metric unit, text size, keep it default. Retailer sheet metric unit. Loading design code IBC 2000. There is a drop down box. You can choose it from there. We are keeping it IBC 2012 LRFD. Steel design code EIC S10007 LRFD. Obviously, whatever the type of method, that should be here also. And earthquake code again IBC 2012. Wind load for Delhi region is 47. You can change it 47 here. Panel engineering, let us make it automatic. So automatic means for the very first time the panel will be designed, but otherwise the panel will be designed whenever there is a change detected. The other is unconditional, that every time it will keep on engineering whenever we are drawing. Semi-automatic means it will ask before it design. And manual is every time you have to provide information to the command to the FrameCAD software to design it. And then disabled means the engineering design is disabled, it will not be designed. Then base engineering. In base engineering there is String method and rigid diagram method. In String method it takes the strength derived from the K bracing as well. But in rigid fluid diagram method it will take strength derived from only the extra bracing, thus X bracing, constant bracing. So we'll take String method. Joist engineering enabled, truss engineering enabled, roof live load. We have already for our building the roof slope is 15 degree, so we can for a slope of 10 degree the live load is up to 10 degree. Live load is 0.75 kN per square meter as per Indian code. For a 15 degree slope we can reduce the live load. So for a 15 degree slope, for each 5 degree slope we can reduce it by 0.02 kN per square. So we can calculate the tail load as this, live load as this 0.75 minus 0.02 into our roof slope is 15 degree, 15 minus 10. So this works out to be 0.65 km per square meter. We take roof live load is 0.665 km per square meter. Terrain factor, we shall keep it 1. Importance factor is same as risk coefficient. Topography factor is same as topography in our terrain factor for less than 10 meter height. We can take it 0.91. And loading earthquake load, this we shall adjust after we create all the model. Now let us say OK. So there are only 3 numbers of border as indicator. We actually required 9 numbers of border. So let us delete all of them. Now again go to B set. So quantity shall be actually 9 numbers and rows 3 numbers. See, other things still remains same whatever we had said before. Now let's make it. Now we have 9 numbers of border. So now we'll go back to the AutoCAD file. Before that we save it as a sample building. File, save as, FrameCAD file folder, sample building, save. So this has been saved as sample building. Now let us go back to the AutoCAD file. Let us select all of the entire ground floor. Press Ctrl C and go back to the FrameCAD file and Ctrl B. Insert within a border. This has been set in the border. Now let us go back to the AutoCAD file again. Let us take this section as well. Select all of them, Ctrl C, then again to FrameCAD file, press Ctrl V. Let us keep the section somewhere outside the border. We are keeping it here because we'll keep on referencing these drawings. So we need that to go back to the AutoCAD file again and again. So we have to make this AutoCAD file temporary. So for this, type in the command bar ls and enter. Select the entire drawing. Enter. See, its color has been changed. Now we have to make it temporary layer. So let us type LT. Layer temporary. So see, it has disappeared from the view. Now if you again type LT, it will appear on the view. I will make this section also a temporary layer. So write LX1 in the command bar. So select this entire section. Enter. So this has also become a toggle layer. So now if I type LT1, it has disappeared. Now retype LT1, it will appear. Like this we can make LX2, LT2 in a series and put a number of drawings as required. Now this is the drawings in which we'll start working. With this, our first two sections ends. We have set the border and we have got the drawings from the AutoCAD file to the FrameCAD file. In next section, we will start with panel setting and creation of ground floor wall and its opening. Let us save the file. Save. So the file has been saved. And exit.